Hello, I'm Dr. Dungey, Professor of Chemistry from the University of Tennessee at Chattanooga. And today we're going to talk about the speed of chemistry. Chemical reactions are all around you. They're in the air, they're in the plants, they're in your body. And the importance of understanding the rate of a chemical reaction or the speed of chemistry is how your body metabolism works, for example. So how your body processes food, how fast it releases energy, all of that depends on the rate of the chemical reaction or the speed of chemistry in your cell. So we're going to do a couple reactions here to show what factors contribute to the speed of chemistry. I've set up three experiments, reaction A, reaction B, and reaction C. And in these experiments, we're going to mix two chemicals, sulfite and iodate, and we're going to vary one thing at a time in our experiment so that we can determine what the result is. So in reaction A, we're going to mix 20 milliliters of the sulfite with 5 milliliters of the iodate that has been diluted with water. So if you look at both beakers here in our reaction A setup, they both have 20 milliliters each. Then we'll change how much iodate solution we add as we try the other reactions. What we're going to do when we mix this reaction, we're going to watch it carefully and see if we can determine a change, a chemical change. And we're also going to time this because, again, we're trying to see how fast is this reaction going to take place. So as soon as I mix this, I'm going to start the timer here. Okay, I'm mixing the iodate with the sulfite, starting the timer now. And I'm going to mix this with the glass stir rod so that the chemicals in the water will come into contact and react. This particular reaction with the iodate and the sulfite is called an oxidation reduction reaction or redox reaction. In this type of reaction, electrons are transferred from one atom to the other. In this case, the sulfur in the sulfite is losing electrons and giving them to the iodine atom in the iodate. And there's actually three series of reactions. So in the middle, in the intermediate, it's going to form iodine, I2. And when we run out of reactant, we'll have a little bit of iodine left over, and that will give us an indication that a reaction has completed. Different things we look for to see if our chemical reaction is progressing. We could check if the temperature changes. We could check if the phase changes. Does it form a precipitate? Does it form gas bubbles? Or another indicator would be, does the color change? And we'll see what happens here once all of our sulfite is consumed. And we're just left with some iodine. Okay, got a color change. So we'll stop that at about 2 minutes and 50 seconds. Now we're going to mix half as much iodate and see what happens. Actually, twice as much. Now we have 10 mils. Let me restart the clock. So we got the color change, time at about 1 minute and 20 seconds. And now we'll double our iodate again and see what happens. Let's reset our timer and mix. Start the timer. So from reaction A and B, we saw that when we increased the amount of iodate, the reaction time was shorter, the reaction was going faster. Now that we've increased the iodate even more, let's see if the trend continues. Okay, so we got a color change at about 37 seconds. So we can see a trend here. When we doubled our amount of iodate, or concentration of iodate, our time was about half. Then we doubled again, and our time was about half again. So the trend here, the amount or concentration of a reactant increased the speed of the reaction. And in other lessons, we'll learn what other factors contribute to the speed of chemistry.